In this video, we're going to look at how you can build custom visualizations of your data directly within your application by embedding the data object of an ad hoc view using Visualize.js. Since we are embedding natively within our JavaScript, this allows us to utilize the data object in any way that we like, rendering with outside visualization libraries, such as D3, and building fully authenticated views of our data in a way that best fits the end user's experience. Let's start by looking at a simple breakdown of the code needed to pass a few values of data to these custom gauges that have been rendered in our sample application using D3. Opening our Live Samples page from the link in the description below, you can view the portion of code that runs these gauges under the Ad Hoc View Samples, Custom Visualization, and the With D3 Gauges fiddle. Here we can see the script tag loading Visualize.js, as well as the attached resources for D3 and a custom liquid fill gauge JavaScript file to render our visualizations. We're rendering our ad hoc data for the gauges within ID Fill Gauge 1 and Fill Gauge 2, making rendering the physical ad hoc view from JRS into Container 1 completely optional. In this case, we are simply after the data and don't need to render the view itself, so we have commented out the container property inside our Visualize.js code. Here we can set up our authentication and build a variable to pass our ad hoc view into. Let's take a look at this view within the Jasper report server. In our ad hoc designer, we can see that we have set up some simple data in our view with percentage units shipped and percentage cost in our columns area, by brand in our rows. By hovering over the chart or switching to a crosstab, we can see our totals. Notice we have a filter set for this view where the brand Giroli is set, and by going back to our code, we can change this filter under Parameters to the brand Golden to update our gauge numbers. To pass the data from our view, we've set up two variables for both percent shipped and percent cost that we will pass our data to on successful load. Let's see what that data object looks like inside our web console. By going to the console, we can discover the structure of our data and how to best reference it. Note that currently, as of the time of this video, we've marked the data object as dataset internal to make it clear that changes may be made in the future to the order of the data object in new versions. Let's open this object now and look at how it can be referenced. We see that our data object has a total for both the brand Golden and for the entire row as well, which in this case only has one item, making the numbers equal. Looking in our JavaScript, we can see that these objects can be referenced for the first value in the data array for percent shipped and the second value for percent cost. Notice the typical array offset where the first value is marked by 0 in brackets and the second by 1, and so on. We also have the ability to pass the number of counts of data, which is helpful when passing more than a few lines. We'll look at an example of this shortly. For now, we can see that once we have our 2 lines of data, we can then pass those into any custom function that we like. And in this case, we make some changes to them to round to 1 decimal place and set percentages inside our custom D3 gauge. It's in this way that we can make changes to our rendered numbers on the fly, and even change the format depending on what our JavaScript dictates. Now let's take a look at a sample application where we use counts to loop through our data and pass several lines into a custom application view that can then be used to pass values into another custom D3 visualization. Keep in mind that while D3 is a common open source charting library, there are endless tools and methods for rendering data in JavaScript. In fact, in this view, we render some of our data directly onto the page, with our numbers for both caffeine and sugar, and the name for each drink used to render the associated SVG for our custom list. Now we can filter what's on the page in any way that we like within our application. Looking at the ad hoc view in JRS that powers this data, we see that we have a table with a few rows and several columns of data. With several of these columns, we pass the ingredient percentages for each drink, and looking back at our application, we can see that these are then passed to our large custom D3 cup visualization. This controls the rendered levels for the ingredients in the view that we can then allow end users to customize as needed. So let's jump into the code for this. Opening the Module 3 and 3.1 folder in our sample application files, which you can also download from the link in the description below, let's take a look at our primary JavaScript file, cafe main.js. Here we can see our drink list table that we are taking our data from, as well as an out-of-the-box ad hoc view that is also rendered on the page. We have these placed in a page config object, which we can then dynamically reference for our views. We're interested in the drink report.uri for our custom drink list, and searching for this, we find a few places in the data it's used. Specifically, we want to look at the custom drink list variable, built from our drink list ad hoc view. While there are many moving parts in this JavaScript, the portion that we are concerned with is where we render the data within our useData function. Moving down to this function, we see the arrays which will hold our data for each column. Here we have several for loops to assist in rendering the data using the num row, which is set by our counts in the data object. The first loop will walk through each column, and within that, run a loop for each row, allowing us to grab the data from our object and place it into the each row variable. We can then render this in any way that we like. In this case, we push each row out to the appropriate array to save the data for each column that we specify. Here we can see an example of how we can then use this data with the render data function, where we can set the text content in the page for the name, caffeine level, and sugar content for each drink, along with other various columns of data. You can explore this function for rendering your data into various elements of your page, and also discover your own ways to render data immersively within your application. By embedding fully authenticated and custom views of your data within your application, you can empower your end users to take the right action in the right place at the right time, directly at the point of discovery.